Okay, students, today I am going to take an assignment problem, and it also a part of your syllabus in the operation research assignment problem. Yes, AIGN assignment problem. So A should come, I think so. Okay, no problem. And this is what matrix structure. Unlike in the previous problems here, we have that. Some persons are assigned to only one machine. That's what one person should not connected to two machines. Only one person, one machine. Like that, we have to assign. So only one person available, and here P2 is the another person available. We are writing only one outside, and the last person available that we are writing at last. Similarly, only one machine available, first type machine, second type machine, and last one is the third type machine. Also we are interested in that. Okay, now in this particular problem, what is the objective function? We know that minimizing the assignment cost is our aim here. So the total cost here, this is the assignment of P1 to M1. Its cost is C11, that is assignment cost. Okay, is C11. So if you multiply this and this, you will get the assignment cost for assigning P1 to M1. If you multiply this and this, I mean X12 and C12, we will get the assignment cost for assigning P1 to M2. Similarly, the assignment cost from P1 to M3 is X13 into C13. Assignment cost from second person assignment to the first machine is X21 into C21. Assignment of second person to the second type of machine, we have X22 into C22. Assignment cost for assigning P2 to M3 is X23 C23. Assignment of P3 to M1 is X31 C31. Assignment cost for the third person to second machine X32 into C32, and assignment cost of the third person to last machine X23 C33. Okay, so if you add all of them, that will give you the total assignment cost. That's what is given here. Okay, minimum is that equals X11 C11 plus X12 C12 plus X13 C13 plus dot 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 plus XMN CMN. M, suppose there are M persons are there, N machines are there, then XMN into CMN. So sometimes this expression is written as, sometimes it is written as, so they are writing like this also. Summation form, that also they will write. Summation of Xij, summation of Xij into Cij, where I varies from 1 to I vary Inj varies from I is varies from M comma N, like that. So it's the short form of the big form. Now what are the constraints here? See, only one person can be assigned to only one machine. Only one assignment is assigned to only one machine. Therefore, as the number of assignment would be X11 is assigned or not, we don't know, plus X12 plus X13. So that should be equal to 1. If it is assigned, it will be 1. Otherwise, it is 0. Suppose P1 is assigned to M1, then it is 1 plus 0 plus 0. So you will get 1 plus 0 plus 0, 1 will get. Similarly, we can assign this particular person for only one machine. Therefore, he can assign here, he can assign here, he can assign here. Okay. So what we are getting is that any one of them become 1, other becomes 0 0. So here 0 1 0 is equal to 1, like that. Last sum of the assignment must be equal to 1. So these constraints based on the availability of the persons. These based on availability of the person. This is availability on the person. So the condition on personality is P here. Okay, on the basis of persons. Now look at this machine semi-guide. So only one machine can be assigned to only one person. Suppose M1 is assigned to P1, then m1 cannot be assigned to p2. As a result, this x21 becomes 0. If m1 is assigned to p3, then this value will be 0 because already we have assigned machine 1 to p1. Therefore, x11 plus x21 plus x31 must be equal to 1. If m1 is assigned to p1, then here we'll get 1 plus 0 plus 0. You will get 1. Similarly, second machine should be assigned to only one person. So any one of the variable xij must be equal to 1, others are 0. So you'll get this equation, this equation. So this is based on what? Based on the machine available. Am I correct? Based on the machine available. Also, one more condition is also there, that's called fusible condition. This is what we say fusible condition. So fusible condition is that the value of xij, you must know that the value of xij must to be always greater than or equal to 0. That's very, very important. Okay. Um, the xij means what? The assignment of the person to the machines. So that can be assigned, it cannot be assigned, but there is no chance for negative here. Therefore, the value of xij must be always greater than or equal to 0. Okay, this is called what we say is a fusible condition. We say what we say fusible condition. This one, f e a s i b l e, fusible condition we say. So yeah, assignment problem is also a linear programming problem. That's what in the examination they may ask like that. Prove that the assignment problem is a linear programming problem. You have to. So in that case, we have proved that this is objective function, and there are constraints are there, and there is a fusible condition out there. Therefore, definitely this is an LPP problem. Okay. So with that, we come to the end of this session. The next session, we will be seeing another problem. Okay. Thank you.